Today we're going to be taking notes on phase changes. To start off with, we have our essential question. How are thermal energy, particle motion, and state of a substance related? Go ahead and write that at the top of your notes. Our vocabulary today is going to be kinetic energy, the energy of an object because of motion. The word kinetic stems from the Greek word for motion. Topic question number 1, to write off in your left-hand side of your notes. What is the kinetic molecular theory? Kinetic molecular theory. The kinetic molecular theory is a theory that all matter is made up of particles that are always moving. These particles hold kinetic energy and move around in random directions. At high temperatures, these particles have high energy. At low temperatures, these particles have less energy. The more energy a particle has, the faster it will move. What is a kinetic molecular theory? Continued. So after watching a quick clip, draw a cartoon of the solid, liquid, and gas particles in the boxes below. Try to show their particles and how closely packed or how far apart they would be spread for both or all solid, liquid, and gas forms. Topic question number 2. What is thermal energy? Thermal energy, or heat energy, is the overall energy of a system. This depends on the type of particles in the system, the total number of particles in the system, or how fast the particles are moving, their temperature. So what is thermal energy? Continued. Increasing or decreasing thermal energy can change a state of matter of a substance. Above is an example of how energy being introduced to an ice cube can cause it to melt and turn into a liquid form, where its particles are moving faster. Topic question number 3. How does energy relate to the states of matter? Right here we've got our energy starting with absolute zero, having the lowest amount of energy, the Bose-Einstein condensate above that, then solids, then liquids, then gases, and then plasmas would be considered to have the most energy of all forms of matter. Solids, in solids such as ice, the particles hardly move at all, and they hold a regular pattern because energy is low and the particles are tightly packed together. So, in each of the state of matter windows, draw what particle's motion would look like if you zoomed in. So again, this is a solid, so solid should have tightly packed, mostly non-moving particles in it that are in a definite shape. In liquids, such as water, the particles have more energy and the freedom to move around. Liquids have the ability to flow and take the shape of the container that they are put in. So in this box, draw liquids and the particles that liquid would have. Remember, it has the ability to move around a little bit more than solids and is a little less tightly packed than solids are. Gases, like steam, the particles have a lot of energy. These particles are sparse and move around freely. Gases are usually invisible to the eye, and they can be expanded and compressed at different pressures. So in this window, draw the particles for gases. Remember, they are loosely bound together and freely move around. Keep that in mind when drawing your particles. Plasmas in a substance that make up the sun and the stars. It is super high energy charged gas particles that collide violently. So again, these are supercharged particles that collide very violently and cause things like fires and lightning and other very energetic natural phenomena. The Bose-Einstein condensate is considered another state of matter. It is a very low density gas that is very cold, has very extremely low energy, and matter in this state has what's called superfluidity and superconductivity, meaning that it moves very easily and defies some of our fluid ideas, and superconductivity means that it conducts electricity very well at cold temperatures. Absolute zero is the temperature of zero on the Kelvin scale, which is a unit of temperature measurement, at which motion of all the particles would theoretically stop completely. All atoms and all particles in the atoms would come to a complete stop at absolute zero. Although scientists have not yet reached absolute zero, we have come close. Topic question number 4. What are phase changes? So phase changes are when a substance changes from one state of matter to another because of an addition or removal of thermal energy. A solid, a liquid, and gas and plasma can all change to other forms. Here we have a triangle showing you which direction each one of these can take to change forms. Gas can condensate into a liquid, or liquid can vaporize into a gas. Condensate requires less energy, and vaporization requires more energy. Same with a liquid to a solid. Freezing requires less energy, melting requires more energy. Then we've got sublimation and deposition over on the left-hand side. Sublimation is when a solid turns directly into a gas, which takes thermal energy. Think of dry ice. Dry ice is named dry ice because when it melts, it leaves behind no liquids. And deposition is when a gas changes directly into a solid. Then you have ionization and deionization at the top, which is how plasma occurs. Ionization is an increase in energy, and deionization is a decrease in energy. Topic question number 4 continued. Label the names of the phase changes and make a color key for the addition and removal of thermal energy. Color the arrows to show which direction energy moves in order for a phase change to occur. Draw or color arrows that are increasing in temperature with red, and color arrows that are decreasing with temperature with the color blue. What are phase changes continued? So dry ice is an example of sublimation. It will melt without leaving behind a liquid. Frost on a windshield is an example of deposition. A cold windshield has an instant freezing layer on top of it with no liquid. That would be a deposition. The droplets of water on the inside of a window is considered an example of condensation, where gas changes into a liquid. And evaporation and boiling are both examples of vaporization, where a liquid changes into a gas. Ionization and deionization. So the gas with an electric current running through it in a plasma ball is an example of ionization, and that causes plasma to occur. Your coloring should end up looking similar to this. You should have the blue, freezing, deposition, condensation, and deionization. And for red, should be sublimation, melting, vaporization, and ionization. Topic question number 5. How does the transfer of energy and the temperature of a substance during a phase change look on a graph? So label each state of matter and color the warming arrows red and the cooling arrows purple or blue. Write the names of the cooling phase changes above and the temperature plateaus, and write the warming phase change below the plateaus. It should end up looking like this. For topic question number 5, your first set on the graph is a solid. Going up would cause melting, and going down is going to still be getting colder. In the middle, you have your liquid with the arrow pointing down on top. There's freezing and melting beneath it. And then above it is condensation and vaporization. Then above liquid, and the least one, is going to be gas at the very top, which is going to have condensation and vaporization underneath it. Make sure to sum up your notes at the very end. You do have questions on the back of your notes. Use your completed notes to answer these questions and make sure you turn in your assignment. Thank you for listening.